Well, I think due to the time, let's start, and I'll let people in as they filter in. So,
Absolutely.
so thank you all, and welcome to our third in this alumni virtual reunion lecture series that we get to highlight our exceptional faculty. Today we have the privilege of Professor Matt Burnett joining us to give his presentation on the emerging role of 3D printing in academia. Matt Burnett is a tenured faculty member in the Camino School of Engineering Technology. He teaches in our GMMD Graphic and Multimedia Design program, and recently became the presiding officer for the Faculty Assembly. He has a Master's of Fine Arts from Maine College of Art and his Bachelor's of Arts from SUNY Plattsburgh. His art is a direct product of his rural northern New York upbringing. He infuses nature and conservation into all of his creative pursuits, which has earned him international acclaim. In addition to his professorship at SUNY Canton, Matthew is a fellow at the Munich University of Applied Sciences. He is best known locally for developing a week-long Adirondack Experience photography course, an immersive experience that uses the region's most prominent assets as backdrops for students' education. Photographs from the course are on display all over campus, including in Southworth Learning Commons and the Cyber Cafe. He was one of the first faculty members to respond to the onset of COVID, and by printing 3D face shields for frontline medical workers from his home. As Matt says, he lives in Saranac Lake with his wife, Amy. So with that, I will turn it over to you, Matt, and I'm going to pin you to the screen so we get to look at you. And if you want to share your screen, go right ahead.
Thanks a lot, Jeffrey. I just turned my face on so you could see me blushing at that really long introduction. But now a quarter of my presentation is done. It's good. But anyways,
you're welcome.
Thanks. So anyways, I'm just going to talk about, really just give a snapshot of what I've been doing with 3D printing the last few years, how it's involved our school and some of their classrooms and some of our relationships with other institutions. So let's see, already we have failure. There we go. Okay. So I don't know how much our audience knows about additive manufacturing, probably a lot. So I'm just going to show the first slide when I do my intro class, which talks about many different methods that we use for additive manufacturing. And additive is not new in a way, but it really describes all these different processes, which include laser sintering and the way we for the lay terminology, that we 3D print with metal and even concrete. There's quite a few ways that we build things, and it just expands our capabilities. I'm going to talk about fused filament fabrication. You may have also heard it called fused FDM filament. What is it? Now I'm going to choke on it. Filament fused deposition modeling. And in some ways that's more commonly used, but that's actually a trademark term, whereas FFF, it's like the difference between Kleenex and tissues. It's like one is a brand and one is a trade, or one is a product, but we're splitting hairs there. Anyways, if you haven't done too much with 3D printing, but you've just heard about it, what it is it's a glue gun on a plotter, okay? This is a model of how it works. The filament currently comes in mostly spools that look like weed whacker material, and then it's sent through a heated end. And the heated end moves with the guidance of the G-code to create the model. I quickly can show what that looks like. So you're seeing the hot end. You're not really seeing where the filament is coming through, and it's building like a little toy or a model. It's actually not a very good print, but you see it's sort of following along the perimeter of the print, builds everything one layer at a time. So anything that's, the model's like 1 inch tall, 2 inches tall, it builds the first millimeter, gets the whole section done. Then it does the second millimeter, then it does the third. So once you've watched it in motion, you get it and you can start thinking in that way. But the first time, a lot of people say to me, I just don't understand how that works. I don't know how you start with something on the computer and it ends up in your box here. That's a long view of the same printer I just showed you, which is kind of a Frankenstein-like one. They call these the Delta models. That came in a kit from China about a year before COVID, and let me tell you, not very user friendly, but it has a really tall build volume, as you can see from the femur I was trying to print. These are the ones we've been using in classroom. They've come down in price. 10 years ago when they're first coming into being more, they were thousands of dollars. You still can buy $1,000 models or multi-$1,000 models. These are actually between 300 and 400 right here, these Cartesian units, which basically means they're just working in XYZ. And that same boat, actually, you can see printed on both of these. It's a calibration model. So anyways, my adventures with 3D printing started. I got a teaching fellowship a few years ago to take a year off from Canton and develop, do professional development. So half of that year I spent at the Munich University of Applied Sciences teaching courses there. And I developed new courses for it, one of which was 3D printing. You could probably tell this was 2016 because I found that sign somewhere and I had to laugh. But anyways, so you've probably heard some of these terms kicked around in realms of 3D printing. Rapid prototyping is a common one. This is one of the first real projects I did with 3D printing, aside from just learning how to use the machines and getting good at it. When you think about prototyping, all the programs in the Canino School of Engineering, where I teach at Canton, rely on prototyping. But the way that industries do it vary from one place to another. And I can say this as somebody coming from the realm of the humanities and art and design, and having worked with people in the sciences, having worked with people in the engineering side of things, we just tend to start in a different place where we're all creative people. And so some of the cliches that you get are true or have truishness to them, but everybody is problem solving. We're all problem solving. And so this first project that I got with was really fun. It was basically a environmental installation, which ended up being done in the Grass River here in Canton. And I had the concept for it in my head, but as often happens with my artistic ideas, you need to find the processes and people to work with to make your dream, your idea reality. And basically what we wanted to do is have two branches of the river flowing with different colored lights and have the lights flow into the same fork of the river and all change to the same color. So you can see a little bit of the schematics and prototyping and early models that we did. I actually had to learn about microprocessors and Arduinos, and that's another part of the prototyping industry that's becoming just more accessible. 10, 20 years ago, to build something from scratch was the province of engineers primarily. You could argue that it still is, but I'm seeing more and more, for lack of a better word, I'll throw out hobbyists that can find the parts, that can find the instructions, that can figure out how to code, that can learn how to put things together and make them, and can buy all the stuff to do it. It can happen under the same roof is the big point I want to get at. So this is out prototyping this project on the Isar River. And that's one of Greg Kai's awesome photographs when we did it here on the Grass River, and he did the time lapse motion, which is why it looks like that. But a really great collaboration between people from the arts, the electrical engineering class here. Just they swooped in and helped us with the immense amount of soldering that we had to do, because we did 100 of those little lights that you see in the hand there, and they each had an Arduino battery wired in and a changing LED. So it went off really well. Like a lot of the art things I do, a lot of people were participating in it, both up front in the building of it and then in the implementing of it, which is part of the idea. But in terms of the classroom interactions, this is some back on the Isar River. You see that my student laughing there with us. You can tell we're having a good time. We were out trying things, seeing how it works, jumping in the river with them to figure it out. And this kid was sharp, the one on the left there. A lot of my students are great, but I remember him. He was bored in my intro class. And then when I started working on this, he just inserted himself. I didn't even invite him. He kind of asked what I was doing and got involved. And the next thing I know, a few months later, with me and another professor and these students were jumping on a U-Bahn to go to the river and test this thing out. And he still kept a dialogue with me when I did this in the States and had more problem solving to do. So anyways, let me quickly move on. I don't want to talk very long on any one of these projects. This is Joe, one of our students at SUNY Canton, and in our lab here. And I got pictures from a lot of different labs. But the lab and learning environment is something that's worth talking about. What desktop 3D printing has allowed us to do is you probably heard the terms like makerspace, and I use that interchangeably with a lab. What happens in a lab is you make things, you try things. And what I'm liking to see in Canino is a realm where we have people, mechanical engineering students, that's actually Joe's background, with graphic and multimedia design students, with science students. I want to mix it together because I think that, like that last project I showed, we need different types of knowledge to solve the bigger problems. So as you might think, this 3D printing revolution comes with it yet another way that we are contributing lots of plastic waste into the waste stream. So another project that's worth sharing a few pictures from is that we actually got funded by the New York State Association for Reduction, Reuse, and Recycling to try to figure out a way to take these failed prints, which you see every time you print an iteration or you print something just for the sake of learning from it, then you end up with another plastic thing. So it either goes into the waste stream, or, as we were working on, can we melt it back down? It's a thermoplastic. Can we make it back down, turn it back into filament? So that's what the green machine there is involved with. And what's interesting is that while the price of the printing technology has gotten pretty desktop affordable, the options for recycling, they're still more at a beta level. They're still much more expensive. I think this was like a couple $1,000s to get rolling, and they've gotten to an even more expensive model now, which tells me, my sense is that the institutions that are getting with this technology, they're either trying to figure it out themselves, or they're so caught up in the what to do with the technology that they haven't caught on to the how to manage the waste from the activity or the technology yet. So, but as all responsible developers need to think about, we need to think about the beginning and end stages of our products. So this was a really, and this is just quality testing the stuff after we, put new filament together back from the old stuff. It's really great to flip it. I already talked about engineers working with artists. What happens when you take artists or design students and get them to work on real technical processes? We have to learn how to be much more methodical, use scientific method. We have to learn to be technicians. And we need to know this for the people that we serve in the graphic realm. If we're representing the way that a process or a discipline is operating, we need to know something about it. So we got a visit from President Zafran here to our lab when this project was pretty far along. And you can tell it was just a great mix of students, and we all were learning together. We took us a little ways to get there, but we ended up with a presentation in the American Society of Engineering Education. So, these students now all have a publication credit to their name, which is not small peanuts. It's a really competitive national level, international level conference. So obviously you can't read the slide, but that's what we presented, and the students did the presentation. Let's see, I'm doing okay on time. I'm at 15. So a few other things that you can do in the 3D realm is there's 3D scanning, there's a couple different processes for doing that. And I'm just going to show you quick slides of what that looks like. So you all know about CAD design, which is building a model up from constraints or mathematical structures or points, lines, and planes. But what do you want to do when you build like an organic shape? Like the students tend to have, that's actually Joe scanning himself. You can scan in color, which is, all aside, this is video games already do this for their assets, and the gaming industry has long had really fairly crude, simple, cost-effective devices for scanning your face and putting it into your game and that type of interaction. Being able, the scanning technology is also at a beta level. It's come along quite a bit further than the reprocessing technology. But to give you an idea of some of the things we were playing with, I had a fellow colleague that designed a clue game with all of our senior administration, the deans, provost, president. And so it was really fun to go and make schedules with all these all my colleagues, and then we had to scan them. And then, what you're seeing there is the scanned information, which is actually a point cloud. Then you have to problem shoot it. Each one of those pink flags is a problem to be solved prior to printing. So one thing I love about it, the maker in me, is I love that students have to start with an idea, they have to build it on the computer, and then they have to understand the technology enough and work through the technology to get a result. It's not like where photography went, where we used to have to know about light and shutter speed and all this stuff, and then go into the darkroom to process to get a result. Now you press a button and you get a result. So the way you teach it is different. It's obviously much more complicated than that, but it's been perfected and automated and simplified. I'd say that 3D printing and certainly scanning is about where home computers were in the mid 80s. It's a wild west. There's people doing great things with it. And it's sort of like sometimes you're working on a machine that has $1,000 part on it, but then they're asking you to use a glue stick to level, or a piece of paper. It's like, it's very early technology still. So this is the kind of organic object that I would challenge anybody to draw in CAD software, but to scan with a type of technology that we have, like those game controllers, is possible. To explain the scanning thing just a little bit more, I actually wanted to show you a mock-up on my computer, but I think I'll stay in the presentation. You can all tell what that part is on the right and the scale of it and stuff. That was scanned on a structured light dies, which basically takes several pictures. It projects a grid of light to measure the contours, then it turns 20 degrees, or you can change how many pictures go to make the cloud. But when you're in, you can see the detail. It's actually captures the rust on the corrosion on the edge of things. People ask me, hey, could you turn that? Would it work? And the short answer is no. It's one solid unit there. So what is the utility of that? If I was going to make this, I need to separate the handle from the part. I need to make all those internal parts. But we have already found some interesting applications, reverse engineering things. We took an intake manifold out of a car, just took the gasket and extended this. I worked with somebody in automotive just to see how it would change the performance of the car. So there are times where it's quicker to scan, or easier to scan what you're doing, than it is to build in the perfect world of CAD design. Hopefully I'm not going too fast. A few more projects to talk about before I finish in 5 minutes. On the left is my colleague, Matt Lutz. He's in the art and architecture program at Norwich University in Vermont. And so we got interested in this together. I actually went to several schools as I got good at this and helped them get their labs set up for teaching this, and his was one of them. And then a year later, he contacted me about a project. He wanted to scan the Wee Lassie, which those of you from around here would know, that's one of Rustrun's signature canoes, and that's in the Adirondack Museum. So everybody knows, everybody around here, wasn't very hard to get access, and they let us in, and you can't really see what he's using, but it's basically a scanner that attaches to an iPad to get a point cloud to build that boat, to get a perfect replica of that boat. So this is fast forward a month or two after we got that, and he's built this boat at Autodesk in Boston. And I'm going to talk about Autodesk a little bit more separately. But the thing you got to know is they have a 3D printer that is big enough to build this boat. Well, he had to build it in 2 sections, but you see, it looks so crazy. It's the same printer that sits on the desk that I was showing you earlier, the blue one. Just a Cartesian unit, uses left and right and raises up for the Z-axis. So I guess one thing you learn is that it's a lot more heartbreaking when you have a 19-hour print fail in the last hour than when you have a 90-minute print fail in the last few minutes. But he was there, and I caught up with him working at Autodesk on that project. A note about Autodesk's model. If you've heard the term makerspace, Autodesk really buys into this concept, and I'm hoping to do a project with them in the future. They have these technology centers in some of the big cities. I think they have one in Montreal. This one was in Boston. And what was great about this is it was a shared, it was a great model of makerspace, the most effective one I've seen so far. And I've been seeing what different schools are doing. It had a room with robots. It had a room with 3D printers. It had a room with the big routers. I'm not saying it right. But had all these tools available to you, and you could walk through and see all these different projects being worked on by different teams from all over the world. And talking to Matt, they ask very little of you. If you win the opportunity to come here, they're just trying to promote ingenuity and prototyping and new ideas, material based. Their focus is material based. But I only interacted with just a few people that were there, but most people, you could look at their desk and see what they were working on. Some people left flyers and literature and videos out, so you could meander through at any time and see what else other people were working on. I love that model, and I've tried to bring that back into my idea of how a lab could work here at SUNY Canton or any of the institutions that I'm still affiliated with. All right, so to wrap up, a few more projects to discuss. I still teach for Hochschule München, or the University of Munich Applied Sciences. Since we've gone to the COVID protocols, I haven't been traveling back there. I've been doing it remotely. And we've actually been doing a 3D printing course, myself and my colleague, Professor Rabin, that is completely online. And I'm happy to say that, like SUNY Canton, we did really well when we had to make that transition. People worked really hard, but we did really well about going into new teaching fast. But other schools weren't as prepared to do this. And I got this, my relationship with another school showed what it was like for a school that doesn't do any of this or very little of this when they had to make a quick pivot. So luckily, Matthias and I had worked together enough that we were able to try something, and luckily it worked almost the first time through. And we managed it by, instead of having turning the students loose on the printers and having them go through 20 iterations to figure out how to problem solve and fix everything, which is how we build the analytical scientific method approach for them, we really emphasize the CAD part. And between Matthias, me, and 2 or 3 other students, there'd usually be anywhere from 4 to 6 printers available to a whole class of 20. So we started just doing teamwork, and we did a lot less printing and a lot more conceptual stuff. But when we got to the printing, we got into teams, and each team would have a printer to manage their own printing. So in the beginning, people would be sending things to the teachers to print. But the problem there is, as you might imagine, you don't want your students to give you all their work to do and they go away for the weekend and you're just working all weekend. They're going to miss out on all the fun and also the immense time requirement that this stuff has. So we really got project based in a way that was better than the times we had done it before. We had 4 teams. They all developed the game. And this is where the German team, they weren't all German, but that's the German university left this game, which is kind of a combination of Legos and dominoes, as you can see there. And they showed a little bit of their design process and what it looked like. I actually did the printing for them, so those pictures of the pieces are mine. Well, we passed that on to our GMMD team, our graphic and multimedia design students, who are doing project management at SUNY Canton. And one of the jobs that was on the docket that a couple students went after was taking this game further, finishing the prototyping and marketing it. And this is what they came up with. So they developed the packaging. They consulted with a few of the students and the teacher that was involved with that first project. And they still had things to fix with the model. I'm really happy to share this project. And I can tell you that this student, this really shows me what is possible at our school, because the best I can say about this team was that they were all very different. 2 of them were distance students. This was during COVID, and only one was there for the 3D printing, and he hadn't yet learned 3D printing. And somehow they all collaborated to make this happen. Now, you know how group work can be. You hear people grumble about it, but this is the kind of thing I want our students doing. Real work with real deliverables that comes from one thing to another, that extends the reach of our partnerships. So we're trying that model again right now. I have more games that we developed and we have student teams working on them. So I'm almost done and I'll have a few minutes for questions. You wonder why there's this dirty picture of a wooden boat here. This is my studio. And during COVID, this is where I was stuck for, well, I wasn't here entirely because I was still doing some face-to-face teaching. But you see, I've got my bank of printers, and at the height, I had, I don't know who has their microphone on, but you see that you see the different kind of activities that take place in my studio, and also a project that, well, it's starting to get in my way, but I am in awe of the people that developed this Adirondack guide boat. I have one that's in working order, and I'm trying to find it. I'm trying to restore this one. So my 3D printing, I love mixing old and new technologies. And so I've been developing 3D printed ribs, which is a really hard part of the boat process. To, almost very few people that go and dig out stumps and slab them and make and dry wood for 2 years to get guide boat ribs. We generally do it in other ways. So it's interesting to test ABS as a printed material and how it holds up to the old spruce ribs, and if it can be a more convenient or even marketable replacement for them. Last thing I'll talk about, Jeff touched on this. When COVID hit, within a week or two, we did hear from state government in more than one way, but some Congress reached out to us, and we're asking if we could help with PPE production, because you remember that everybody was talking about toilet paper being scarce and all this stuff, but in the medical field, we were short on masks, we were short on PPE. They were talking about ventilator parts. There's lots of stories floating around the world about 3D printed ventilator parts. And what was interesting, and I'll say a learning experience for me, it's a moment like that in your life that you ask, how good am I? How has all this time that I've spent playing with machines, printing little boats, learning how to troubleshoot them, teaching people about it, can I do anything with it? What can I do with it? And I don't have time to tell the whole story here, but the numbers were that the network that I became a part of, and there's actually somebody in the audience here tonight that was doing some work with that too, Ben Smith. They came together within a week to 2 weeks. There were some people that knew how to organize this. It was called the North Country 3D Printing Network. We really did well. I think we got something like 2,500 face shields. This is actually an early model that didn't end up getting used. And even there, that tells you to get all these different printers in different parts of the North Country to print the same thing, troubleshoot it the same way, get it where it needs to go, and give it to hospitals in a way that they can actually use it. We had to get really organized in the right way. And I had to learn quite a bit more about how products are vetted in that kind of realm. And I'm really proud of the work that we did. We were able to move much faster than industry. I had requests from other parts of the country that we connected to. We really served New York, but I heard from hospitals down in South Carolina that were short, and we sent them a box of these things. And I'm still trying to find time to write about it for journals. But what does it mean when academia or hobbyists, it wasn't all academics, but can move faster than big companies or big manufacturing centers that could produce 2,500 of these things in one day once they're up and running. So it shows some potential of being able to move quick, move small, and reach the whole world. It really is an interesting time to be working with this stuff, and I'm really proud to be part of it. Okay. And that is my presentation. So hopefully I didn't run on too long. And if you have any questions, I could take them.
Thank you, Matt. Are there any questions? Well, I think I don't think we have any questions. Thank you so much for your presentation. It was fascinating to watch that. I know that 3D printing is all over. I think in Plattsburgh they're 3D printing titanium parts, something like that. So it's this is an awesome thing you are sharing with our students, and I'm sure our alumni are glad to have seen what you're doing. Great examples. So thank you so much for your time, alumni. Thank you so much for joining us. We have one more shameless plug for tomorrow. Our last of the series is Pop Culture, Nostalgia, and a Bit of Games with Professor Morgan Hastings. And that is tomorrow at noon. I hope you can join us then, also on Zoom. And thank you again, Matt, and everyone. Have a great day.
Thanks, everybody.
Take care.